Yeah, so hi everyone. This is going to be a lecture on steady state, sorry, not steady state, state space analysis part 2. So we are doing one sort, right? So already we have done one sort, I think, on state space analysis. So we will be covering entire control system in next 4 to 5 sessions, right? So you have to be ready for that, and I hope you might have enjoyed the very first session, right? So, in this session, what I'm supposed to do here is, I'll talk about, state space analysis part 2. Okay. So, since I told you that what is the prerequisite for understanding state space analysis is the matrices. Okay. If you have deep knowledge about matrices, so you can solve any question based on this, right? And it's a simple question. It's a simple concept you will get in the gate examination, and certainly one question you can expect, right? That is the reason I started with this, and after this I'll talk about Nyquist plot. Okay, and I'll cover all the important questions which has been asked in the gate examination. So yeah. Okay. Now, so let us start the session. So last time we have discussed about you know uh, how to find the state model. So let me recap from the last class. Okay, so recall the state model was, or you can say state equations are like, x dot, or the differentiation of vector, state vector is equal to a times x plus du. Okay, so most of the students do not know this also, right? So you should know this equation, right? And output equation y is going to be cx plus du. Okay, so there are four matrices which plays an important role. A matrix is called state matrix. I think you guys know how to find their order and all. So A matrix is known as state transition matrix, or sometimes we call it state matrix. B is the input, you know, input matrix. C is going to be output matrix, and D. Okay. So and there are four different representation of okay. So one is CCF. Second one is OCF. OCF is nothing but CCF transpose of CCF, and diagonalization, right? Diagonalization. Okay, these are the forms, okay, in which we express these matrices. Okay, diagonalization, or we call it normal form. Okay, and this is first, this is second, and this is third, and last one is Jordan block. Okay, Jordan. Okay, Jordan block. Okay, form we call it, right? So please remember these important concepts that I have discussed already. So in this session again, and one important problem also I have discussed about how to get the state, how to get the state model. Okay. These state model you can get in CCF directly from the given differential equation, right? From given differential equations, okay, given differential equations, and from, you can say, from the given transfer function, right? Okay. So please remember this. Okay, from given transfer function, from given differential equation, how you can obtain these state models. Okay, so these are the forms, right? So in the options you have to see whether they have asked you in controllable canonical forms. So I've given you the structure, the basic matrices structure, in which you have to write CCF. Okay, and you have to write OCF. OCF is nothing but the transpose of CCF, right? So please remember these things. So these two problems that you can expect. Okay, this model. So I believe this was fine from the first session, right? And now what I'm going to discuss here is, I'll talk about uh, okay. So already we have discussed this, and I've discussed the by inspection method also, right? So in this session I'll talk about diagonalization form, right? diagonalization form, right? Okay. See, if you know the concept, you can solve any question, right? So diagonalization form. In matrices, I have taught you diagonalization matrix as well, where only non-zero element is going to be what? The principal diagonal. What is diagonal matrix? Diagonal matrix is going to be the matrix which has only non-zero element which are present in the diagonal. Other elements are going to be zero. So your state transition matrix is going to be what? Simply the diagonal element is going to be non-zero. That you have to make sure, right? So diagonalization form is one of the very easy, you can say, state model form, right? So uh, suppose we have got a transfer function, right? Suppose, okay, suppose we have got a transfer function by s by us, right? Okay, us means your input and by s is the output, right? Suppose this kind of a transfer function is given, and the numerator is 1 upon, and s plus 1, s plus 2, okay, and s plus 3, right? So numerator has got like s plus 1, s plus 2, s plus 3, these factorized. You have also factorized the denominator, right? And the numerator is constant here. So what you can do here is I'll tell you the shortcut as well, don't worry, I'll tell you the shortcut. Okay, so if you want by inspection method, so I can tell you quickly, okay, but let me first discuss the method 1, right? Okay, method 1, to write in diagonalization form, right? So first of all, what you have to do, you have to go for partial fraction expansion. आपको क्या करना है? First of all, you have to go for partial fraction expansion, right? So do partial fraction expansion. Remember, partial fraction expansion, right? See, a matrix you can directly obtain from the given transfer function. I'll tell you, right? Don't worry, I'll tell you how to get this. Okay, but first of all, you do the partial fraction expansion. I think anybody can do this, right? So the partial fraction expansion is gonna be what? A upon s plus 1, b upon s plus 2, right? And c upon s plus 3, right? This is your bias by us. So you have done the partial fraction expansion. Now you have to find the a, b, c value. So I'm not going to tell you how to do partial fraction expansion. I think everybody might be familiar. I'm just gonna write direct, right? So your bias by us, and since these are the s equal to 1 here, s plus, okay, so you have to find a value, you have to find b value, you have to find c value, right? It's a very simple one. So I'm just going to find, I have got already, so you can say that 1 by 2 s plus 1 minus 1 by s plus 2, okay, plus 1 by 2 s plus 3, right? So these are the values that we have got already. Now what you do here is you take this by u this side, okay, you multiply with numerator here. So by s is going to be equal to, you can forget about by now, right? Sorry, you can forget about this s s variable, right? So needless to write s, okay, you have to implicitly assume that there is a s, okay, your output is a function of s, but forget about s now, right? Because now I'm going to write everything in terms of state variable. So this is by, which is output, right? 1 by 2 u, right, upon s plus 1, okay, minus u 1 times u, right, s plus 2, and this is 1 by 2 u s plus 3, right? Okay, I hope this makes sense to all, right? So what you can do here is you can consider that by is going to be equal to, this is x1 plus x2 plus x3, right? This is your by, right? You can consider by is equal to what? X1 plus x2 plus x3. You can let here, okay, let x1 and x2 plus x3 is this, right? So what is this x1 and x2? You see, x1 is going to be 1 by 2 u upon s plus 1, x2 is going to be minus 1 u by, okay, s plus 2, and x3 is gonna be 1 by 2 u by s plus 3, right? So I think it is very simple, right? Given a transfer function, you have to do the partial fraction expansion, then find out the a b c values, whatever values, and then y equal to, you take u this side, okay, then consider x1 x2 x3, right? Now let us manipulate, okay, let us take this guy first, okay. So you can say that your x1 is nothing but 1 by 2 times u by s plus 1. Now you multiply, you cross multiply, okay, cross multiply. So this becomes, x1 dot s plus x1 equal to 1 by 2 u, right? So what is this, suppose we have got dy by dt x1. So we can write this as s time x1, right? This is nothing but a differentiation. If you multiply anything with the s, okay, in frequency domain, so that becomes the differentiation, right? So it is a first order differential equation. You can say x1 dot, okay, differentiation of x1 dot vector of, this is state vector, right, is going to be equal to minus x1 plus 1 by 2 u, right? So this is the first equation that you can obtain. Okay, I believe this is fine. Next, you can consider x2 here. So x2 is this. So x2 is going to be minus 1 times u by s plus 2. Again, you can do cross multiplication. So you will get here x2 dot going to be equal to minus 2 times x2 plus minus 1 times u, right? Okay. And you can also get x3, right? Because, okay, x3 is what? x3 was this. Okay. We consider x3 is this 1 by 2 s plus 3. तो यहाँ से आप निकाल सकते हो x3 dot is going to be equal to minus 3x3 plus 1 by 2 u, right? I believe this is the second equation and this is third equation, right? So since you have got all these equations, so you can now write the canonical you can say diagonalization form. What is that? You write here x1 dot, x2 dot, x3 dot, right? And then you write here what? In the first equation only what is the coefficient of x1 here? That is minus 1, and there is no x2 x3. So what you will do here is you will write minus 1 0 0, right? Now second equation you look at, here the coefficient of x2 is minus 2, but other guys are 0, right? So you can say that 0 minus 2 0, right? And 0 0, you can say minus 3. Okay, this is the A matrix that you have obtained, right, in diagonalization form. Let me tell you guys, this matrix you can write directly as well. Okay, but here I am giving you the detailed procedure. Okay, I will tell you how to write directly, right? These are nothing but what? Minus 2, minus 1, minus 2, minus 3. These are nothing but poles, or sometimes we call it eigenvalues, right? Eigenvalues, okay? Poles or eigenvalues, right? Okay, please remember. So here it is going to be x1, x2, x3, right? And the input matrix is going to be what? Input matrix. You see, in first case there is a half, second case minus 1, third case half. You write here half, minus 1, half. Okay, half, minus 1, half, right? And your output by is going to be what? That is 1 1 1, because x1 plus x2 plus x3 you have considered. Here x1, x2, x3. Okay, so this will be always 1. Remember, in diagonalization form, this will be always 1. Always 1 1 1, right? Remember, right? And what is this? Let me highlight all of them, right, so that you guys can understand. These are nothing but the poles. Okay, these are nothing but the poles plus eigenvalues. Okay, and what are these? These are nothing but the coefficient of partial fraction expansion, right? Okay, from the partial fraction expansion, okay, like ABC value. Okay, so I think A matrix you can directly obtain without doing partial fraction expansion, but after factorizing the denominator, after factorizing the characteristic equation, you can get the this diagonal elements, all diagonal elements, and A matrix you can obtain. But how to obtain this B matrix? You have to do the partial fraction expansion, right? So these are the coefficient, coefficient from partial fraction expansion, right? Understood? Okay, And what is this? This will be always 1. Please remember this. Okay, so let me take one. Okay. And in diagonalization form, this B and C matrix can be interchanged, right? One more thing that you have to understand. This is B matrix and this is C matrix, right? So this also you have to note down. Okay. In diagonalization form, okay, B and C matrix can be interchanged, right? Okay. So in the question, if suppose B matrix is kept there or a, okay, you don't have to worry about that. It is not wrong at all, right? So I will give you. I think this is clear, right? So you can try questions, okay? You can try questions, and I think this is clear. Okay, please remember this. Okay, how to write diagonalization form? Diagonalization form. So first of all, what you have to find? You have to find the poles and put them in the diagonal. Okay, that is the reason you become good in linear algebra, right? So that you can deal with these concepts. Okay, now let us talk about Jordan canonical form, JCF, right? Jordan canonical form. Jordan canonical form. Okay, though the important is CCF and OCF only for the gate examination, but these are also important sometimes. Okay, so Jordan canonical form. What is this Jordan? See, in Jordan canonical form, what will happen? What will happen? You will be having a repeated. You can say, suppose you have got y of s upon u of s, right? And you have got a transfer function of this kind, s plus 2 square and s plus 3, okay, like this. Okay, now you have to write this is the transfer function. You can also write in diagonalization form, okay, but let us write in Jordan form first, right? Let us write in Jordan form. So what is the first step that you have to perform in this case? Is the first step is do the partial fraction expansion here also, partial fraction expansion. So if you don't know partial fraction expansion, let me know. I'll tell you the partial fraction expansion how to do quickly, right? Uh, so here you will get you can say that there will be a partial fraction expansion, right? So you can say that a by s plus 2 whole square, b by s plus 2, right, and c by s plus 3. Okay, so you'll get all these things, right? So you have to find a, b, c, right? So you will get here you can take this side also. So y is going to be 1 times s plus 1, sorry, s plus 2 whole square times u, right? Okay, suppose you got a value that is 1, okay, and b value you got -1, so you just write here -1 times u by s plus 2, and then you got 1 only, right? C value as well, so s plus 3, right? So you have taken this u this side, right? That's it. Now what is the next step? Whatever you have done for diagonalization, you have to do here also. You take y equal to x1 plus x2 plus x3. Okay, understood? But in this case, you have to notice here is that this x1 is nothing but minus x2. Okay, understood? So x1 equal to minus x1 minus x2 plus x3. Okay, this is very important to remember. Okay, this is very important to remember now. So x1 minus x2 and okay. So you have to write like this. Take the sign also -1, right? Okay. So C matrix directly you can obtain that C matrix is going to be what? 1 minus 1 1. What is this? This we will obtain. We obtain from partial fraction, okay, expansion. Okay, these are the coefficient like ABC. Okay, these values are ABC. So C matrix directly you can obtain, right? Okay. I think this is clear for all, right? I think this is clear. Now what you can do here is you can take now x1 is this, x2 is this, x3 is this, right? And you can write, so what is this x1? X1 is nothing but u upon s plus 2 whole square, right? So you can write this as u by s plus 2, okay, times 1 by s plus 2, okay. You can write like this because here s plus 2 whole square is given, fine. So u by s plus 2 and 1 by s plus this, okay. So what you can say here is that x1 is going to be, what is this? You can consider this is nothing but x2 here, right? You see, you can consider this is nothing but x2, okay. So you can write this as x2 by, understood. So u by s plus 2 is going to be x2, right? You can write this as 1 by s plus 2 and x2, okay. You can write like this. So x1 is going to be x2 by s plus 2, right? Just you have taken this minus sign with by, so don't take minus sign here, right? So you can say that this is going to be sx1 plus 2x1 equal to x2, okay. Now you see what is this, x1 dot is going to be equal to minus 2x1 plus x2, right? Minus 2x1 plus x2. This is going to be number 1. Okay. I hope this makes sense. So this is the first equation that you have got. The next equation that you will obtain is, again you take x2. So x2 is going to be u by s plus 2, right? So that minus sign you have taken with the with by, okay, with C matrix, okay. So don't worry about that minus sign. So u by s plus 2 here, right? So now you can take the, again, so it is x2 dot equal to minus 2 x1 x2 plus u. So this is second equation, right? And the third equation which you will get is x3 is going to be u by s plus 3. So you can say x3 dot, I mean dot will be there, is going to be minus 3x3 plus u, right? Now this is third equation, right? Third. Now you can what you can do, you can write in Jordan form. So let me write Jordan canonical form, right? So Jordan canonical form. So there will be a Jordan block, we call it partition of the matrices, you see. So here I'm going to write all these state vector, differential state vectors. There are 3, right? Next one is going to be what? First is having, you see, minus 2, 1 and 0, right? You can check. First equation minus 2 and 1 and then 0. Second equation minus 2 and 1, right? Here. So second equation is there, minus 2 x2 is there. So this is 0 minus 2, and it is going to be 1. And this is going to be 0, 0 minus 3. Perfect. I think this is clear. Okay. And here you can write this is nothing but x1, x2 and x3. Right? Okay. Plus B matrix. So B matrix is going to be what? You have to write, you have to understand. See, this B matrix is not the is not obtained from the passive fraction expansion. That you have to keep in mind. Okay, that you have to keep in mind. Understand? So this B matrix will be what? You have to understand the block here, right? Jordan block we call it. You see, this is the root which is repeating here. So you can say this is going to be your Jordan block. Right? Okay, this is the Jordan block. I'm partitioning this A matrix like this. Okay, where this minus 2 and minus 2 it is repeating here, right? And here 1 and 1 is there, right? So okay, please remember. Okay, this is the block, this is the matrix where the roots are repeated. Okay, you can say this is where the repeated roots are there, we call it Jordan block. Okay, so you guys can check my partitioning, how do we partition the matrix. So this is what the matrix you have partitioned, right? So as you move ahead, right, and try to, so what you do here is you try to write here in first case. Okay, in first case In this case, you write 0, it will be 0, right? And here it is going to be 1, okay, and below that, that is also going to be 1. Okay, you can see 1 1 only, right? Okay, so you have to make sure that how do we choose this Jordan block. Okay, how do we choose this Jordan block, that you have to understand. The first one is here, right? Above that, all the all the components should be 0. This vector here, it should be 0, and below that everything should be 1. All the components should be 1. This is very important in case of B matrix. Okay, so this is a Jordan block. -2 -2. Okay, so we have partitioned this matrix, right? So please remember, this is important to keep in mind. And your bi is what? Your bi is going to be 1 -1 1, right? And this is x1 x2 x3, right? So we obtain this from the partial fraction expansion. Okay, please remember. I think this is clear. Okay, please remember this. This is important. Okay, to keep in mind, right? So if you can remember this, it will be worth for you. Okay, to solve the questions, right? So and quickly you can solve the question. That's what I can assure you. Okay. So yeah. So let me move ahead and tell you about let me solve one question quickly, right? So the question is there, right? Now what you can do, guys, you can try PYQ, right? PYQ, try and apply my concepts, right? And check whether you are able to get the answers or not quickly, right? By inspection. तो मान लो एक क्वेश्चन दिया हुआ है, ठीक है? Suppose you have got one question by u by s by us is given, which is given as 1 upon s plus 5 cube, right? And s plus 10, right? In this case, you can write the Jordan canonical form, right? Jordan canonical form directly. कैसे देखो, in A matrix you can write directly. So A matrix will be -5, right? Okay, -5. Remember, this is -5, then -5, and above that there will be 1, right? All guys will be 0. Remember this. Okay, this is very important to keep in mind. And how many poles are there? That will be the order of the matrix, you can say, right? So there are 4 poles, you can say 4. Okay, so -5, start with -5, then put in the diagonal. Okay, -5. Now here -5, so this should be 1, right? Above the diagonal there should be 1 always. That you have to make sure, right? Now this is -5, this is -5, this is -5. Now this should be -10, right? So okay, please remember, so don't put 1 here now, right? Okay, so this will be 0, this will be 0 0 0 0, right? 0 0 0, right? This is going to be your A matrix, which is in Jordan canonical form. Jordan canonical form. So you have to make sure that this is the trick that I'm telling you, right? So above this there should be 1, above this there should be 1, but above this no 1. Okay, please remember. What is the Jordan block? If you want to decide which one is Jordan block, the Jordan block, you can say, is going to be this. This is going to be a Jordan block. Okay, if you partition this matrix, okay, if you partition this matrix, right? So the -5 -5 -5, it is getting repeated. So this is going to be your Jordan block, right? Now how do we obtain the B matrix? So B matrix, you can go like this. Okay, you come here. Okay, you come here. So the Jordan block ends here. So you say this is 1 and this is 1, and above everything is gonna be 0, right? Please remember this. Okay, so this and this for this. Okay, so 0 0. Okay, from where the Jordan block ends, that should be 1, and below that 1, and above everything should be 0. This is B matrix always, right? And how do we obtain C matrix? C matrix we obtain from like you can say K1, K2, K3, and K4. Okay, understood? So these are the partial fraction expansion. So you need to be good at partial fraction expansion. If you're good at partial fraction expansion, so writing A matrix, writing B matrix, and writing C matrix will not be difficult. Though A and B you can directly write. And remember how I'm showing you the Jordan block, right? Jordan block ends when the repeated roots ended, right? Okay, please remember this. Okay, so in case of Jordan block, there will be a repeated roots. Okay, so this is the concept that you have to learn. Okay, so all models I have covered, right? And now I'll talk about what? I'll talk about state model to signal flow graph. Okay, state model to signal flow graph. Signal flow graph. Okay, so please remember state model to signal flow graph, right? Now they will not give you the state, you can say transfer functions and all, right? What they will give you, signal flow graph. And from the signal flow graph, you have to directly write the state model. See, if I'm talking about state model, it means we are trying to find what? We are trying to find x dot, okay, equal to ax plus bu. We are writing in that format, okay? So you can say, we have to find the matrices, that's it, okay? Okay, so how do we write this state model from the signal flow graph? That is very important. And you should be able to write directly, because in future what they will do is they will give you one signal flow graph, okay, and they will ask you whether the state, whether this is controllable or observable or not, right? Okay, controllability and observability they will ask, okay, in future, whether this state model is controllable or you can say observable, right? So you should know directly. But what people make mistake here is what like what gate aspirant make mistake here is, suppose signal flow graph is given. So first of all, they try to find the transfer function, okay, they will invest some time over there, and then they will write the state model in CCF, OCF, or you can say Jordan canonical, or so you don't have to do that. You have to avoid those things, right? What you have to do, you can directly write if you have got the state model, okay, and if your range of vision, if your observation is clear, right, so you can directly write it. But you should be able to look at the signal flow graph carefully, right? And you should always look at the arrows, right? How we are going from input to the state variable, right? Input to the state variable, okay? So the way you apply node equations, the similar way you can write the equations here, and you can get the A matrix, B matrix, C matrix. So I'm gonna show you, right? Okay. So suppose we have got one signal flow graph, okay. Suppose we have got one signal flow graph. So I'm just going to show you. So signal flow graph will be like this from input to output, okay. Suppose this is input here, okay, and this is the first node, okay. You can say 1 or 2, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, and your output is gonna be 5, right? This is by, okay. Now let us connect all these things, right? So please remember, from here to here, this is 1, right? And this node is connected like this, right? And focus on this arrow, right? This arrow, okay? Always keep in mind this arrow is having -3, and you can say from here to here it is 1 by s. Okay? What is this 1 by s? See, s times something is the differentiation, right? S is s is what in frequency domain. It is the equivalent of differentiation, right? And 1 by s is gonna be the integration, okay? That you have to remember. So 1 by s, right? And you can say here also 1 by s, here also 1 by s, okay. Okay, so you just connect now all of them. So from this node it is also connected, from this node it is also connected, right? So don't write the transfer function, guys, from the state from this SFG, okay, signal flow graph. Directly you can write the state equations and you can get the matrices, right? State model. देखो मैं बताता हूँ कैसे. This is -5 and this is -7, right? Now we can connect these guys, this node to output, okay, this node to output. ये ऐसे connected है, right? So you can say this is 6 and this is 4. Okay, and this is connected, you can say there is a 2, right? Now we have got this state model, right? Sorry, signal flow graph. Okay. This is the signal flow graph. See, now I'm telling you all these techniques, right? So you can take any book, you can take any question, you can apply these concepts. Okay, everywhere the by inspection technique is valid. Okay, by inspection मतलब आप देखकर बता सकते हो आंसर, राइट? सो आप सेव कर सकते हो टाइम, है ना? अगर आप टाइम सेव कर पा रहे हो तो आपकी लाइफ में बहुत अच्छा हो रहा है ना। टाइम सेव करो ज्यादा से ज्यादा, जैसे एनालॉग में टाइम सेव कर पा रहे हो, मैथ में कर पा रहे हो, नेटवर्क में करो टाइम सेव, राइट? टेक्निक सीख करके, ओके, टेक्निक सीखो, है ना? फाइन। सो लेट मी मूव अहेड। ओके, ये स्टेट मॉडल याद रखना, ठीक है? अब आगे की बात करते हैं। तो सपोज यू हैव गॉट दिस, राइट? अब आपको स्टेप नंबर 1 में क्या करना है, ठीक है? सबसे पहले आपका काम क्या है? सबसे फर्स्ट काम, व्हाट इज द फर्स्ट स्टेप दैट यू हैव टू परफॉर्म व्हेनेवर सिग्नल फ्लो ग्राफ विल बी गिवन, राइट? Okay, whenever signal flow graph will be given, what is the first step that you have to perform, guys, right? So let me take this. ये signal flow graph I have taken and I can make it small as well, no problem. Here it was looking very big, fine. Okay, so what is the first step? Let me write here the step number 1. Okay, so first of all you have to select the node as a state variable. Yeah, you have to select the node as a state variable. You see how many nodes are there? 1 node, 2 nodes, 3 nodes, 4 nodes, 5 nodes. There are 5 to 6 nodes are there, right? You can say, okay, like starting with, so there are actually one input node, one output node, so you can ignore them, right? So take node like this, okay? So there are some nodes, right? And you have to assign some state variable to the nodes, right? So the first is to select the node as a state variable, okay? So it should be like this, always remember. Suppose this kind of situation is there. So this is these are the 2 nodes and this is the incoming, you can say this node has got this incoming arrow 1 by s. So there should be one integrator present, right? Okay, between 2 nodes there should be one integrator. So suppose this is x1 dot. Suppose you take this node as x1 dot. So this should be x1, okay, because that will integrate, you know, so the differentiation effect will be gone. Understood? So this is very important to remember, okay? So the node which is very close to output, okay, you have to take it like a x1 here, okay? So if it is x1, so what is this? X1 dash dot, you can say, okay? If it is x1, right? The node which is very close to by, okay, you can take it x1. That is very first step that you have to start with, right? So x1 is the state variable. You have to assign the state variable to the node, okay? So node which is close to by, so you take x1, and if you come back, you know, so what is the incoming? That integrator is coming, right? So before the integrator there should be something differential of the that state vector, right? X1 dot, okay? Now you can say that this x1 dot is going to be equal to x2, right? So this node should be what? This node should be x2 dot, okay? Understood? So if you take this guy is x3, right? So you can say this is nothing but x3 dot, right? You can take like this. I think this is clear. Okay, I think this is clear, okay? Please remember this. So this is nothing but x3, this is nothing but x2, and this is nothing but x1 dot, okay? Differential state vectors, differential state vectors, okay? So this is very important. So now we can write, okay, now you have to, second step is what? First step, assign state vectors. to the node. Assign state vectors to the node. Order, I hope you understood. X1 should be very close to output, then X1, then X2, then X3. X3 should be close to, you can say, input, right? Okay. And suppose X4 is there, so X4 should be close to U, right? This is very perfect observation that you have to make, okay? Understand? And where you have to assign this state vector, where this integrator is present, okay? If integrator is not present, don't write. See, I'm not writing anything here because there is no integrator, right? There is no integrator, right? Okay. So there are three integrators. So there are three state vectors we have assigned, right? Second step is going to be what? What is the second step? Second step is going to be focus on incoming branches now. Incoming. So focus on incoming branches, right? Okay, so let me write x3 first. X3 dot, right? What is coming here? You see, 1 times u. After that, you can arrange it, rearrange. 1 dot u is coming, and this is coming here. So you can say this, and don't take now differential operator here, right? In this case, it is x3 because you are writing x3 equation, right? So it is coming like this. So -3, you know, you can say x3 here, and this is again coming. That is x2 is coming, -5 x2, and x1 is also coming here. So you can say -7 times x1. Okay. So I think you can write this equation, right? So this is the first equation that you can obtain. Now you write for x2 dot. So focus on x2. x2 is here. Incoming is what? Okay, incoming. Okay. So this is x2 dot. Okay. Don't take integrator now, right? It is outgoing. Okay. So you see what is outgoing here, right? So in case of by yes. So in this case, x2 in x2, okay, you see here x2. What is coming only is it is only one, that is this. Okay, x2 is nothing but x3 only, that is second. No other branch are incoming, right? So this is very simple, right? If something is not incoming, okay, so don't focus on that, right? Only x2 dot is equal to x3. One equation that you can get, that because that integrator is coming now, that will give you x3. So x2 equal to x2 dot is going to be x3, right? And no other branch, no incoming branch are there, right? In this case, no incoming apart from one integrator. So x2 is very simple. And what is this x1? X1 dot. So what is coming here? You see, I believe nothing is coming in this case, right? I believe nothing is coming in this case. Only x1 is going to be, x1 dot is x2, okay, and nothing is again coming. So you can say that x2, that is third, right? That is third. Okay, so it's a very simple procedure that you can obtain. Yeah. So only you have to observe incoming branches. Right? तो अब देखो यहाँ से हम लिखते हैं, so it is x1 dot x2 dot x3. Okay. Now, I think by without writing these equation also you can write the matrices. Okay, if you focus on the incoming branches. Okay, but I will make sure that you just assign all these state variable. So from the first equation, what is this? Only x2 is non-zero, so it is 0, it is 1, it is 0, right? 0 0 1, and you can say this is going to be -7 -5 -3, -7 -5 -3. It is canonical form, right? Controllable canonical form, it looks like x1 x2. Yeah. Okay. Now your B matrix is gonna be what? 0 0 1. You can check because this U is present only in case of x3, not in other cases. So 0 0 1, and your by is going to be what? By will be okay. You see by, this by. So you can write all incoming branches are coming, right? So you can say that by is going to be 2 times x1 plus 4 times x2 plus 6 times x3, right? So 2 4 6, 2 4 6 x1 x2 x3. Okay, I believe this is fine for all. Yes. So I think you guys can write now. Okay, so just practice state model, how to write a state model from the signal flow graph, and we'll meet in the next session again, right? So take care, and we will you can let me know how was this session and whether you learned something or not. So be confident. State signal flow graph is given. You take any book and write down the state model from given by inspection. Just look at the computer screen and try to make yourself habitual.